Okay, y'all, so the lesson that you would have gotten in class on Thursday is what I'm doing now. And it's on polynomials and factoring. It's not really that difficult. So I'm going to talk kind of fast and get through the problems. If you're watching a video, pause, rewind, whatever you need to do. All right, so polynomial, you have the definition up here at the top, and it's a little convoluted, but basically it's saying that you have a polynomial if you have terms that are being added or subtracted. Terms are things like 2x squared, 5x to the third, like nothing too crazy. What's important to you is what's in this box. For it to be a polynomial, you have to have whole number exponents, no variables in the denominator, and real number coefficients. All right here you have just some key vocab to make sure you know what's going on. The leading term is the term in the front. The terms are the individual pieces that are being added and subtracted. The constant term is the one on the end. Remember, standard form is when I write the problem in order for my exponents. So like if you have this problem, standard form would look like this. You have to put your exponents in descending order. The other thing that's not on here that we're going to talk about on the next slide is degree. And remember, degree is just the biggest exponent. All right. So what is this going to look like in your assignment? You're going to be given some functions, and you're going to have to say, is it a polynomial or not? If it is a polynomial, can you put it in standard form? Can you give me the degree? So number one, we have pretty exponents, so all whole numbers, and the coefficients are real. So yes, this is a polynomial. And it's actually already in standard form. And the degree is 3, because that's the biggest exponent. All right, number two, because you have a variable exponent, that is not a polynomial. So you say no and move on. Number three, you have a negative exponent. So that is not a polynomial. Number four, your exponents are all nice, pretty whole numbers. You got a 1 and a 2. Your leading coefficient, or your coefficients, are all real numbers. They're not pretty real numbers, but they're real numbers. So this is a polynomial. If I write it in standard form, we want the biggest exponent first, so pi x squared, then the 0.5x, and then the constant term. And the degree is 2, because that's the biggest exponent. All right, so now, can we add, subtract, multiply polynomials? So, if we are adding, we are literally collecting like terms, sorry. So, 9x to the 5th, and then we have a 6x to the 4th. Then we can combine our x to the thirds, and then we just have an x. We want it in standard form, so if you'll collect your like terms going biggest exponent to smallest, you'll be in standard form. All right, so number 6, since we have subtraction, you can distribute that negative and replace this with 4x squared plus x, and then just collect your like terms. So we have negative 8x to the third minus 4x squared. Combine the x's, and you have plus 5x, and then minus 1. All right, another subtraction example. Remember that it's going to make this guy negative and change this one to negative. So collecting those like terms, we have these that match. So 4 minus 3 is 1 of those x squared y's. Then you have your 7xy. And then you can combine your constants, so that's negative 2 minus 8 is negative 10. All right, number 8. You have multiplication. The biggest mistake that people make is they want to multiply when it's adding. So make sure that you pay attention. If there's nothing between the parentheses, that's multiply. If there's a sign between the parentheses, then do what it says. All right, so to multiply polynomials, you distribute everything in the front to everything in the back. So 5x times 3x is 15x squared. 5x times 7 is 35x. Negative 8 times 3 is 24x. We're just going to let that ring for a minute, y'all. Sorry. Negative 8 times 7 is negative 56. Then we combine any like terms that we have. And we're done. Oh, I don't know why this is not happening. Oh, there it is. All right, so number 9. If you remember from the previous lesson, these are conjugates. So the outside inside is going to cancel. So I only have to do 8x squared times 8x squared. And 5 times negative 5. All right, on number 10, you're multiplying the same thing twice. So if you think about it, you're going to do 3x times 3x. You're going to do 3x times 2 times. So 3x times 2 is 6. If I had 2 of those, that would be 12x. And 2 times 2 is 4. On both of these last 2 problems, if you work them out just like number 8, it will get you to the final answer. It'll just be an extra step. That's fine. All right, number 11. If I do 2x times x squared, 2x times negative 3x, 2x times 6, and then negative 5 times x squared. I'm going to write underneath because I'm running out of space. Negative 5 times negative 3x, and then negative 5 times 6. Combine your like terms. When I wrote it underneath, I kind of put my like terms together. So when I combine those like terms, I get that. All right. Let's see if I can move this. I should be able to. Okay, whatever. We're going to see if we can make this fit. I was going to try to give myself more room, but I couldn't. All right, so multiplying here, I'm going to get 18x to the third y squared. And then I would get negative 72x squared y and 45xy squared. So then it's 5's turn. So that would be 10x squared y squared minus 40xy plus 25y squared. All right, that should be in one long line because there are no like terms. So there's a plus sign that connects this line with this line. That should all go across. I just didn't have room. All right, so the next section is on factoring. So we want to factor completely. Oh, I went 2 slides, y'all. Back up. Here we go. We want to factor completely, which means we're going to take out a GCF at first, and then look at what's left. If that GCF comes out, look at what's left, and it depends on how many terms you have. If we have 2 terms, then you're hoping that it's a difference of squares or some difference of cubes. If not, it's not going to factor. If you have 3 terms, we use the guess and check method, and 4 terms, we use grouping. All right, so number 1 has a GCF of 2x squared because 10 and 4 are both divisible by 2. And both of them have x's, and we take the smallest amount. All right, so then I divide 3 by that. So 10x to the third divided by 2x squared gives me 5x. 4x squared divided by 2x squared just gives me 2, but it's positive. But my buttons are all covered up. Gives me negative 2. All right, I would make that little squiggle go away, but I can't get to my eraser, so that's just 5x minus 2. All right, so number 2, I have 2 terms, and this x minus 7 is common, so that is my common factor. If I divide this whole term by x minus 7, those x minus 7's cancel, and I have 2x. If I divide this term by x minus 7, the x minus 7's cancel, and I have 30. All right, number 3 is probably the one that's going to be the most difficult for y'all to understand, and it's because you've never factored with fraction exponents. And I'll share an extra video of that if you need to see it. You also understand that I don't put anything that difficult on your test. You just need to have seen it before. So it's here. You'll have 1 or 2 on your assignment, but there won't be any on your actual test. All right, so again, this has 2 terms, and this x minus 1 is what's common. Well, just like with variables, we're going to take out the smallest amount, whatever the smallest exponent is. So x minus 1 is the common factor. And if you have a 1/2 and a negative 1/2, negative 1/2 is smaller. So my GCF is x minus 1 to the negative 1/2. Well, if I take this term and I divide by this, they just cancel and I have an x. If I take this term and I divide by this, then you're saying that you're taking this, dividing by this. So you're going to get x minus 1, and you're going to have to do 1/2 minus negative 1/2 to get your exponent. So that's 1/2 plus 1/2, which is 1. So you just have x minus 1, like in parentheses if it makes you feel better. But those parentheses don't really serve a purpose. So I'm going to call it 2x minus 1. All right, number 4. I have no idea where that problem came from or why I picked it, so we're going to change it. We're going to say 7x to the third plus 28x squared. Actually, I think I wanted that to be minus, but that's okay, whatever. So we'll do minus 2x minus 8. All right, so when you have 4 terms, you factor by grouping. So you're going to group the front 2, group the back 2. Sometimes you have to rearrange your terms so that your groups have GCFs. Usually you don't. All right, so these first 2, they have 7x squared in common. So when we divide that out, 7x to the third divided by 7x squared is x. 28x squared divided by 7x squared is 4. These 2 guys have a negative 2 in common. So if I divide negative 2x by negative 2, I get x. Negative 8 divided by negative 2 is 4. All right, so now we have a common factor in these terms of x plus 4. And when I divide that off, I get these little pieces that were in front as what's left. All right, y'all, you learned how to factor in Algebra 1 and Algebra 2. And those of you that took advanced math, you factored in there too. That's why I'm going through this quickly. But again, you can pause and rewind, and I will share extra videos to help if you need them. Okay. Sorry if y'all actually heard that. That was weird. Okay, moving on. So we have 3 terms. So we're going to guess and check. There is no GCF. So let's see. To get 6x squared, we need 2x times 3. 2x times 3x. To get 7, we need 1 and 7. So we'll put 7 here and 1 here. This gives me 21. This gives me 2. That will give me my 19 if the 2x is negative. So negative there, positive there. I am done. All right, number 6. Again, 3 terms, no GCF. So guess and check. To get 3x squared, we're going to do 3x times 1x. To get 4y squared, we're going to do, if I do 2 and 2, so if I put 2y and 2y, I'm just going to get 6 and 2. So that's not going to get me to 13. So I'm going to try putting a 4 here and a 1 here. They should have y's on them though. And then both of them negative, because that way I do get my plus 4y squared. But when I try to get the middle, I'm going to have negative 12xy minus 1xy, which does give me that middle term. All right, so number 7, that one I believe has a GCF. Everybody is divisible by 3 and has an x. So that leaves me x squared minus 10x plus 25. All right, so if I try to factor this with guess and check, I know I need x and x. Since it's a 25, I bet I need 5 and 5. We're multiplying to get a positive, adding to get a negative, so they're both negative. And I could just write that as 3x times x minus 5 squared. All right, number 8. If you notice over here, do you see how, I just pointed with my finger like you could see it, y'all saw it. On number 7, this was a perfect square and this was a perfect square. So it worked out where I had the same thing twice as my factors. So it's perfect square trinomial. I can recognize those by seeing perfect squares and then asking myself, if I take the square root of the front and the square root of the back, if I multiply those together and double it, so 5x, if I double that, do I get that middle term of 10x? Yes, so I know I have a perfect square trinomial. So number 8, if you look at that one, you know you have a trinomial, right? And you know that this is a perfect square and this is a perfect square. So if you think about using their square roots as your first thought, if I do 4 times 7, that's 28. If I double it, I get my 56. So I can jump straight to use their square roots and then you get the same thing squared. So you can skip this step if you recognize you have a perfect square trinomial. All right, so number 9, you have 2 terms, no GCF. You have subtraction, so it's either a difference of squares, a difference of cubes, or it does not factor. Well, it's a difference of perfect squares. So you're going to get the same thing twice except the sign. You're going to have a plus on one and a minus on the other, because that'll make conjugates, which makes that middle term go away. All right, so the square root of 81 is 9. The square root of x to the 4th is x squared. So if you have a difference of squares, you're going to do their square roots added, their square roots subtracted. So the square root of 81x to the 4th is 9x squared. The square root of 16 is 4. All right, number 10, you have subtraction again, but you don't have perfect squares. You have perfect cubes. For perfect cubes, it will factor if you have addition or subtraction. For perfect squares, it only factors with subtraction. All right, so we have a difference of cubes. If you look at page 72 in your book, there's a nice little formula to use. I prefer to memorize like a saying than the AB junk that they have in the book. But look at page 72. If that works better for you, then use that. The way that I always think about it is when I have a sum of difference of cubes, I'm going to have a short parenthesis and a long parenthesis, a binomial and a trinomial. The binomial comes directly from the original problem. What are the cube roots of those numbers? So the cube root of 125x to the 3rd is 5x. The cube root of 8 is 2, and you keep that same sign. So cube roots keep the sign. That's your first one. Once you have that short one, to get the long one, you look at the short one, and you say first term squared. So 5x times 5x is 25x squared. Multiply the 2 terms together. So 5x times negative 2 is negative 10. And change the sign, so positive 10x. And then square the back. So negative 2 times negative 2 is positive 4. All right, so again, small one, that's their cube roots, same sign. Long one, where you do square the front, multiply together, change the sign, square the back. All right, y'all are going to have a quick check and an assignment. Pay attention to the directions in your post to know what's due when. Let me know if you have questions.